So I was asked to do this. So I guess I'm doing this. So let's see. Remainder theorem. I got the remainder theorem here. What does the remainder theorem say? It says if I look at my divisor in the form of x minus a and I plug a into my function, I should get the remainder as if I divide it. So what is that? Well, in this case, a is 4. Because remember, it's in the form of x minus a. Excuse me. So that means I just take my function that's right here and I plug 4 in everything. So that's 4 cubed minus 2 times 4 squared minus 13 times 4 plus 20. Well, 4 cubed is 64. 4 squared is 16 times a negative 2. That's negative 32. And then 4 times 13. What is that? That's 12. Carry the 1, that's 52. So minus 52 plus 20. So then I combine my negative and positive. I got 84 minus 84. Lo and behold, my remainder is 0. So another way of thinking about this is that x minus 4 is a factor of that. So then here, simplify the radical expression. I got a bunch of radicals that we're adding together, but the radicals aren't the same. And so I need to break down each one of the radicals to see if I can get something that is the same, so then I can add them. Well, 45 breaks down to 9 times 5, and then if I take the square root, that ends up being 3 square root of 5. And then if I break down 20, that's 4 times 5, and then I take the square root of both, and then that ends up being 2 square root of 5. So now I've got 6 times the square root of 5 plus 3 times the square root of 5 minus 2 times the square root of 5. So that ends up being 9 square root of 5 minus 2 square root of 5. So the answer is 7 square root of 5. So right here, multiplicity is how many times something is repeated. Well, in this case, I got x squared minus 1. I need to factor that first. That's the difference of squares. So if I take that as a difference of squares, that's x plus 1 times x minus 1. And then we've got x plus 2 to the second power times x minus 5 times x minus 6. So now I'm trying to find my zero. So I got a zero of negative 1 with the multiplicity of 1. Multiplicity of 1. And then I've got positive 1 with the multiplicity of 1. Then I've got negative 2. Negative 2 with the multiplicity of 2. Of 2. So then next I've got 5 with the multiplicity of 1. And then finally I've got 6 with the multiplicity of 1. And that's my answer. Okay. And then we already kind of did this, but might as well finish it. So I got 2 minus x to the fourth power. I write it all out in extended form, and then I multiply what I got. 2 times 2 times 2 times 2, that's 16. And then negative x times negative x times negative x times negative x, that is x to the fourth power. It's positive x to the fourth power because all the negatives cancel each other out because there's an even number of negatives. So first term is x to the fourth. Last term is 16. So consider the following polynomial. Is x minus 5 one of the factors? So then there's a couple ways you could do this. You could try the remainder theorem. You can use the remainder theorem. And if when you plug in your a, you get 0, then it's a factor. You could also do synthetic division. And if your remainder is 0, then you got a factor. So I guess it all depends on how you want to do it. So let's try the remainder theorem. So in this case, my a is 5, and then I just plug it in. 5 cubed plus 8 times 5 squared plus 16 times 5 plus 5. So that's 125 plus 5 squared. So that's 25. 25 times 8 is what? 200. And then 16 times 5, that's what? 80. Well, I can stop right there because all these numbers are positive and I'm not going to get 0. So the answer is no. I could try synthetic division and see if I get, so I bring down the 1. 5 times 1 is 5. I get 13. Let's see. 5 times 13 is 65. So 65. Add those together and I get, what is that, 81. And then 5 times 81, see, that's 540. So that says I have a remainder of 410. Well, again, that's not. So because that's not 0, that means no, it's not a factor. So you got a couple ways you could show. And then you got simplify and write the following expression in standard form. Well, now I'm just adding stuff that's alike. So I got x squared and I got x squared. I've got a constant 9 and I got a constant 1. I got x cubed and I got a negative 5x. So that's it. So a negative x squared plus positive x squared. Then I've got 9 plus 1. Then I got negative 5x. And I got 9x cubed. So that goes away. That goes to 0. This becomes 10. And then I've got negative 5x and 9x cubed. So now I just write it in standard form. 9x cubed minus 5x plus 10. And that's my answer. So right here, I'm trying to find the quotient. Quotient just means I divide. We've been using synthetic division. I mean, you could use long division, you can use tabular method, but synthetic division seems to be the easiest. So first thing I do is take my A, and my A in this case is 3. Next, I write down the coefficients in order. So I got 2, and I got 3, and I got negative 2, and I got 9, and I got negative 12. So now, first I bring down the 2. 3 times 2 is 6. 3 plus 6 is 9. 3 times 9 is 27. 27 plus 2 is 25. 3 times 25 is 75. And then, what? So I'm I've got, man, where's my pen at? So I've got -9 and 75. So that is positive, what, 66? And then I got 3 times 66. That's 8. And that's 19. And so then my remainder ends up being 186. So that means my answer is 2x cubed plus 9x squared plus 25x plus 66 plus 186 over x minus 3. And that's my final answer. And then finally, I got this right here. So what's the degree of this problem? Well, even though it's not in standard form, the highest degree is 6. So it's even. That's what I want to know. And then what's the sign of the leading coefficient? Well, the leading coefficient is -3, so negative. So I could rewrite this in standard form first, so then it's easier to see. So that's -3x to the 6. And then here, those two terms are the same, so I can put them together. So let's see, that's -2x cubed, excuse me, plus 9. So that's my leading coefficient is negative, and then my degree is 6. So according to my little chart right here, if I'm looking at even with a sign is negative. As x goes to negative infinity, y goes to negative infinity. And as x goes to positive infinity, y goes to negative infinity. And that's it. That is everything.